Hello everyone, this is Marika Lamro, and this video is going to walk you through the steps of hand calculating an independent samples t-test. And the first thing that we're going to do is we have this little video that may be a good metaphor for how you feel when somebody's trying to get you to do more statistics.
拍他呀，拍反手啊！洗澡吗？
让我偷他吗？
啊，你跟他说。
行了。
洗澡。
洗澡去，来，快开始来。起来，起来，去洗澡去，快点，开始来，来，来，快起来。来，起来，去洗澡来。来，来，来，来，来，去洗澡来。去洗澡。来，去洗澡。 哎呀，去洗澡，来，来去洗澡来，来呀，快点，哪拉不动啊？起来。
So perhaps you feel like that dog and you just play dead and hope that nobody notices you if the teacher asks somebody to calculate something, and then as soon as you think you have an opportunity, you run away at the first chance. And I understand that feeling, but it's going to be okay. We're going to walk through the steps of calculating an independent samples t-test, and you'll see that it's really not that hard. So let's begin. This is the sample problem that we'll be working with, and I will go ahead and read it to you. A cruise line wants to find out if people are happier taking cruises with city or beach destinations. They ask 6 people on a beach cruise and 6 people on a city cruise to rate how happy they are on a scale of 1 to 10, with 10 being the highest rating possible. Is there a difference in how happy the beach and city cruise people were? And if you look, so here's our data again, and before we start even calculating anything, we need to figure out the null and the alternative hypothesis. And when you're looking at an independent samples t-test, what you are doing is you're saying, is the mean of these two samples the same thing? Or is it different? So when you have a single sample t-test, you are looking to see if the mean is different from a projected mean. And most frequently, you're looking to see if that mean is different from 0. So when you're doing a single sample t-test, you might ask a question such as, is the number of drinks that I get on a day when I'm hot significantly different from 0. When you're doing an independent samples t-test, you can compare two different groups' means. And so we're going to compare the mean of the beach cruise people and the mean of the city cruise people. And when you express that in a null hypothesis, what you're saying is, I think that there's no difference in how happy people are with beach versus city cruises. And when that's expressed mathematically, that comes across as H naught indicates that the mean of the beach is equal to the mean of the city. And the alternative, I know this may look like a lot of formulas and it may look like a lot of notation, but it's actually not that difficult. If you're starting to panic right now, just take a deep breath. We're going to get through this together and it will be okay. So when we're looking to calculate our t, you can see that in the top left-hand corner is the formula for the t-test. And the t-test you need to know the means and you need to know the standard error of the mean. And then we have a formula for the standard error of the mean. And to calculate the standard error of the mean, you need to know the pooled variance and the number of data points you have in your sample. And to know the pooled variance, we have a formula for that, and that you need the sum of squares and the degrees of freedom. And we have a formula for the sum of squares and a formula for the degrees of freedom. So we have all the formulas that we need to calculate our t. And if you're wondering what that d is Cohen's d, and it's the measure of effect size that we'll be using. All right, so now we're going to calculate the sum of squares. I know that sum of squares should be really something you guys are very familiar with calculating, but in case you're not, I'm going to review it very quickly. So we know that the mean of the sample is 6.33. I'm assuming you know how to calculate an average. So let's go ahead and look at what the sum of squares calculation looks like. So now we need to do x minus the mean for each score, so for each value of x. So you can see that that means that you take each score and subtract away the mean. Then, if you follow the formula, you need to square those values. So 1.33 squared is 1.77, 0.33 squared is 0.11. So now we have all of the squares, and we need to sum them, which is why it's called the sum of squares. And that's what the sum of squares formula looks like with the numbers input in there. So the sum of squares for beach is 17.33. Now we're going to do the same thing for the city data. The mean is 2.67. You subtract out the mean from each score of x, then you square all of those values, and this is what the formula for the sum of squares for the city looks like. So now we know the sum of squares for the beach and the sum of squares for the city. So what next? Well, let's go look at the formulas. And you can see, now that we have the sum of squares, we can calculate the pooled variance. So again, here are the formulas for pooled variance. We need to know sum of squares, and we need to know degrees of freedom. We already know the sum of squares. We just calculated that. And now we need to make sure that we know what the degrees of freedom is for the two samples, for beach and city. So n for our sample is 6. You can count that we have 6 scores for beach, and you're going to subtract 1, and so that means the degrees of freedom for the beach is 5, and the degrees of freedom for the city is the exact same thing. So now we know our sum of squares and our degrees of freedom, and we can calculate the pooled variance. So the pooled variance is very straightforward. It's just 17.33 plus 3.34 over 5 plus 5, which equals 2.07. And now we have our pooled variance, and we can calculate the standard error of the mean. So here's the formula for the standard error of the mean again. So the standard error of the mean, again, is a really straightforward calculation. We just calculated the pooled variance, and we know that it was equal to 2.07. So you just plug and chug, and you end up with a standard error of the mean of 0.83. Again, we come back and we look at our formulas, and oh my goodness, holy moly, now we can calculate t. This is very exciting. This is what everybody's been waiting for, I know, to get to the point where we could actually calculate t. So let's do that. It's very exciting. I hope you guys are excited. So here's the formula for t. We have already calculated the means. We've already calculated the standard error of the mean. So t is just going to be a really straightforward formula, and we found that our t equals 4.42. And the last thing that we're going to do is we're going to calculate the effect size, Cohen's d, and we know what all of that is, and so Cohen's d is equal to 2.55. Okay, so now we know our t-calc and we know our Cohen's d, and we need to express what this means in some way. Did people have a difference in how happy they were at the beach or the city or not? We don't know. Well, the way that we're going to answer that question once we've calculated t is we're going to look at a t-table. This should look very familiar to you. It is the t-table. You've already used this for the single sample t-test, so all we're doing is we're going to use it again for the independent samples t-test. When you have an independent samples t-test, the only new thing that you have to track is the fact that there are 2 different samples. So instead of having 1 degree of freedom, you have 2 degrees of freedom, or 2 values for degrees of freedom. And the way that you handle that is really very simple. You just add the degrees of freedom for the 2 samples together. So in our example, the degrees of freedom for both samples was equal to 5, so 5 plus 5 equals 10. So we want to be in the row for the degrees of freedom equal to 10. Now we need to figure out which column to be in. Unless otherwise specified, you can always assume that it's a two-tailed test with a p level or an alpha level of 0.05. That's the default kind of test that we always do, alpha of 0.05, two-tailed test. So we need to be in this column, and if you put your fingers together and run one finger down and one finger across, you end up with a t-crit value of 2.228. And we'll compare that to our t-calc value, which is 4.42. So that means our t-crit value is less than our t-calc value, which means that p is less than 0.05. So we have a significant result. So what does that mean? We're going to go back and look at our null and alternative hypothesis. Since our t-crit is less than our t-calc, that means we reject the null and we support our alternative hypothesis. Let's remind ourselves the null was that there was no difference, and the alternative is that there is a difference. And so that means that there is a significant difference between how much people like beach and city cruises. And the way that looks when you write it up in APA style is you would say people are happier with beach cruises than city cruises. And you report the means and standard deviations and all of the statistics you calculated. So T, P, and D. So we're done, and you have worked your way all the way through calculating an independent samples t-test. And if you are saying to yourself, oh my gosh, this was not enough, I'm freaking out, I need more support, there's so many things that you can do. You can email me, you can come to my office hours, you can email the TA or go to the TA's office hours, you can contact a classmate, or you can go to the tutoring center. So you have a lot of options for how to get more support if you need it. Please don't feel like now that you've seen this video once, that's it, you're out in the wind and there's nothing you can do. If you have more questions, there are lots of ways for you to get those answered.